Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Lumen, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Illumin's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Illumin's website at www.illumin.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
Hi, everyone. Welcome to another edition of the AI Innovation Space. We have a distinguished guest with us. His name is Sumeet Singh. Welcome, Sumeet. How are you doing today?
Hi, Yanu. Thanks for having me. I'm doing great. Yanu and Todd, it's great to be here.
Yeah, and then I have my co-host with me here, Todd. Todd, how you doing?
Very well, thank you.
Awesome. So, Sumeet, I think a good way to get the conversation going here is to really ask you basically, how did you get into AI, ML? How did it start for you?
Yeah, so my first encounter so I would actually go back to my graduation days in Indian Institute of Science, where we had a lot of AI subjects and we also had neural networks. So, there was classical AI, and which, after taking that, I felt like it was just a bunch of algorithms and it was a bit underwhelming. And then we got to the neural network subject, which when I took that, it kind of just blew my mind. And I was so impressed by it that the first emails I got, those are all based on the neural network algorithms. And the one that I liked the best at that time was Boltzmann machine. So the first emails I got were like Boltzmann at, Hotmail, Gmail, etc. And so that's where I got introduced. And I was like really very impressed with the neural networks. Unfortunately, at that time, there weren't many jobs or labs doing this work. So in the late 90s, I joined an AI lab at the National University of Singapore. That the lab was called Institute of System Science. And we were doing computer vision and face recognition there. But we were doing a little bit of neural networks also, but not that much. But basically, that's computer vision. That's where I got into it. And later, however, it became the winter of AI at that time. So again, not much happening there. And the techniques we had at that time, this is pre-GPUs, those were not producing great results. So then I switched into like networking, internetworking, because internet was a big thing. So I switched into that. And later in the early 2010s, when there was a resurgence of neural networks and deep learning, so then I got back into the field.
I see. So you kind of paused your work in machine learning for like over a decade or so?
Yeah. I went into operating systems and communication systems, networking, and then later data synchronization, big data management, and security. So I kind of, went around, but mostly my focus was always computer science. So even when I was working in the networking space, I was working with a lot of IETF RFCs. And later in big data and data synchronization, it was always about innovating and building something new. So in 2016 at Symantec is where I kind of went back and started to use neural networks for security use cases and threat prediction. And from that point on, I've been doing this again.
I see. So can you give us a little bit more about like how if you're running an antivirus or security system, like at Symantec, what they use neural networks for? What's the end goal?
Yeah, so they used a lot of statistical and classical AI, random forest, XGBoost, etc. So a lot of that in predicting signatures, predicting viruses, and predicting threats. And then also neural networks in basically in going through the stream of events that's happening and figuring out if there is a threat actor in that stream. So there are products, various products inside the security space where you collect events and logs from an enterprise. You kind of instrument the enterprise and you collect various events that are occurring. And then this is a constant stream of events that's flowing. And your job is to detect threat events that are happening and pop them up. And they usually show up in a dashboard, etc. So for the IT folks to see. And in many cases they are benign, but in some cases they are not. So for follow-up. So a lot of that is hand engineered, and there is like a whole industry that creates an ecosystem that creates signatures, which you can actually apply on the stream, and you can detect if, for example, there are certain vulnerabilities being exposed, or whether there are some threat signatures of known threats that are being exposed. And but then AI would be used to detect zero-day vulnerabilities or zero-day threats, which is something that's happening for the first time, and that you don't have a pre-computed signature for. So that's where we would use AI for.
Okay, thank you for sharing. Yano, any follow-up questions on any of that?
Yeah, so I'm very curious as to the data sets that were being used and their inputs, what the inputs were to the data sets that are used for security related work. I see you smiling. You kind of know where I'm going.
Yeah, well, that's a very good question. And actually that was one of the biggest one of the biggest challenges was that, because billions and billions of events that are being collected in a matter of days, and any kind of model has to stand up to that. That's number one. And the second thing is training them would be a humongous task, because we had such a big data set. And this is again, at a time when neural networks were not really that, they were not being used in security, honestly. So even if you take like random forest and those other algorithms, or the handcrafted ones, you still have to deal with a lot of data. So, and these are mostly categorical, features. So categorical features means usually there are some agents that are sitting in various places which are emitting discrete events. And so it would say something like, this signature, for example, it detected this signature, for example. So that's a very discrete event. And so I remember in one of my data sets, I had like hundreds and hundreds of columns, and which then I had to reduce it down to like 150 or something like that, and create the cardinality set for each of these. So very, very discrete events and categorical, not continuous. Usually in neural networks, usually you expect continuous signal, except in the case of LLMs, in which case, it's just tokens which are discrete. So one of the main challenges, and then we tried so many different tools that were coming out at that time, and most of those were actually in the big data space. So, Apache Spark, H2O, which H2O people don't even hear about that much these days. And then big data lakes for storing this data, mostly around the Hadoop and Elasticsearch ecosystem. And then lots of technology for managing the streaming, because the streams are coming from actually hundreds of thousands of enterprise customers, and then they're being uploaded and then collected. So a lot of technology, a lot of work going on in that, and then cleaning up that data or exploring the data. So once that you have the data, then exploring it to find out what parts you want, what you don't want. You do one, if you just put the data into a Hadoop cluster and you do a query, it'll take several hours to return back. So that's just not going to work. So we were also building methods of querying really fast by caching a lot of data into memory. And so for that, we had a full Elasticsearch cluster that we went really deep into. We went into the code in order to find out how we could effectively prime the caches to enable us to do fast queries for exploration. So exploration was like one big issue. And then training on GPUs or without GPUs, that was like another, and actually the statistical machine learning was not done on GPUs at that time. It was mostly done on CPUs. So we would have clusters of lots of machines and hundreds of CPUs, terabytes of RAM for working with this data set. So data set was actually the biggest advantage actually that Symantec had, because we had a lot of data. The problem was also challenging because surfacing these events in a way that they can actually be acted upon. So your precision has to be really high, because if your precision is low, then it's just a fire hose of events, and people can't really do much with that because there's so much stuff coming out. So then to be able to sieve them out or filter them out using various techniques, clustering, etc. So that, you cluster them, and then you just show the cluster centroid, like just one. So that way you can reduce the amount of data that you're showing. So if there are multiple events of the same type, you have to figure out how to cluster them, etc. So yeah, so you hit upon the right question. Like the big fire hose, that was quite a major issue to deal with, and we had like a huge data lake to store it and manage it.
So you seem very focused on innovation when you were with Symantec. So how were you getting all these ideas to try the new things you guys were talking about in the machine learning space? Were you reading academic papers and trying to borrow ideas from other areas, or can you touch some more on that?
Yeah, so mostly academic papers. So I would say there's a two-pronged answer here. One was just dealing with the data itself and the data preparation, the data processing. So for that, we worked in we spent a lot of time in evaluating lots of products which are coming out there. So there was like there's some products coming out from Facebook, some even from the government, and there were lots of vendors around this time, 2013, 14, 15, 16. Lots of vendors out there who were selling big data products. So my group, we might have evaluated 20, 30, 40, 50 different products for various things, like for the streaming part, for storing and analyzing and exploring, quick, fast queries. So one part was to keep doing that so that we could become really fast and effective at exploring the data and processing it. So that part was mostly about trying out the technologies that were available to us. So that was one part. The second part was, yes, reading lots of academic papers and then trying them out. So inside Symantec, there were two groups. One was Symantec Research Labs, and another one was Center for Advanced Machine Learning. And then both of these were under the umbrella of Symantec Technology and Research. So there was like one big group. So the whole job of this group was to do research. And so that was basically the thing about it. And there was also another group that was tasked with basically watching for new threats and responding to them. So that was a threat response team. I wasn't part of that, but their whole job was to basically just watch for any new vulnerabilities and any new threats, and then basically write signatures for those or come up with, mostly signatures and different kinds of logic that would get automatically sent or downloaded into all the various Norton and different products that Symantec had. So all the way it would just get pushed down to those. So that was like one team which was doing just that. And going back to your question, so on our case, we basically did a lot of experimentation.
I see. Very interesting to hear how that worked. That's very insightful. Thanks.
Awesome. Another question that I actually had also for you was, is it possible to discuss about, AI and education just in general? I think there's a lot that still needs to be explored as it pertains to AI and education. I think a lot of existing tools are built off of the foundation of Aristotle, and just dates way back to universities being set up and things like that. But I think there is a whole lot more that could still be done, even though we have some tools that have really disrupted the education space, like but a lot of those are even more on the, I guess, learning side of the picture, just really, Udemy, deep learning, but I'm not seeing as much of, I guess, AI tools being developed, maybe in the VR space, and things like that. But, can you shed a little bit of light on like AI and education and how you see it in general?
Yeah. So AI in education, so I can kind of divide it again into two parts. One is AI applied to learning, and the other would be AI applied to assessment. Okay, so on the assessment side, you have summative assessment and formative assessment. And on the summative assessment side, basically, so for example, there are products. So there's a product that I worked on at Turnitin, it's called GradeScope. We do a lot of AI on the grading, on the summative assessment, so on the grading and feedback side. So automatic grading, for example. So you can, so you upload handwritten assignments, and then there's a full pipeline that will go and analyze that assignment, break it up into questions and answers. So, there's a lot of computer vision that needs to be done there. And then extract the answers from there. And then if those answers are simple, for example, they are really short text, or if they are like multiple choice, then we can automatically digitize those. And then there is a method to for the instructor that what they can say is, for example, if this is the answer, then give them 1 point, or if this is the answer, then give them 2 points, and they can then apply this grade en masse across all submissions. So that makes the grading much faster, because what they are doing is now they are grading and question by question rather than paper by paper. So that's one. Then another actually internal, so like research kind of product that we are working on, and we actually already have models, are taking the short answers, and which are basically not multiple choice, but they are like a piece of text. It could be full page or it could be smaller, and then grading those automatically. So this, that's like another thing. Then another set of products, features which are already out there have got to do with feedback. So there's one product that can take an essay, and the essay could be multiple pages long, and it can actually give feedback on specific areas of that essay. And this feedback actually comes from, ultimately, it is sourced from teachers and assessors who are experts in basically in the subject, in writing, in English writing, for example. So feedback is another place where we provide AI, and this is all in the summative side. So basically what we are talking about here is that when an assignment is submitted, there are products that help the teachers to grade it faster, and that also help the teachers provide feedback on the assignments. So that's like one category of product. And the challenges obviously here are around long answers and answers that pertain to different subjects. So writing English essays is one thing, and I know that's a big category. But then there's so many other STEM subjects. So there's chemistry, there's medical science, there's physics, maths, through the different grades, starting with basically elementary school all the way to high school and university and college. So Turnitin does make such products. Other companies also do. So that's like one area. And then another area is the formative assessment, where you start interacting with the students when they are doing their assignments, and you start giving them feedback so that they can improve their assignment. So that's like another category. And a lot of NLP and NLU in this area, a lot of classical NLP and also modern NLP, which is language models, etc. And in both cases, these get applied heavily. And on the learning side, actually, that's where I think there will be a lot of exposure of AI, because that's directly exposed to students, not necessarily to administrators or to teachers. So you might have seen recently, there is this product called Khanmigo from Khan Academy. And that was developed with ChatGPT. So that is basically a tutor bot. And this is like one manifestation of a tutor bot that everybody can it is very popular because it's related with ChatGPT. But there also have been attempts like this in the past. And there are companies in education space which take niche areas like mathematics, and they create these tutor bots for helping kids to learn math, for example. And in that case, what would happen is the child gets given a module for learning, and they learn, and then they're given exercises to do. And based on how they did in that exercise, then the AI figures out what next module to give them. And in this way, every student gets a tailor-made coursework based on where they are, how they are doing, etc. So this, to me, this is like really, this is very close to my heart. And I think if we could scale this, and if we could scale it reliably, we could give high quality education and personalized education to students all over the world. And yeah, sorry, you were saying something, Yano?
That is so cool. And that is equally very dear to my heart, because the flip side of that is that we can then, have it translated in various, translations, Spanish, all,
right.
Translations, and really have this education in mass. Like, I think that would really, really speed up, learning, just like all across the board.
Yeah, I agree. And so imagine, I'm just going to take a slight detour. So there are a lot of online classes, and you mentioned those, Udemy, and Stanford has some, MIT has, open courseware. And I've done a few of those, and I thought that I'm so lucky that I get access to this high quality content from these great universities. And so what I'm thinking is, if that kind of content was made available to students all over the world, but in a more personalized way, in the way that I said, that every kid, based on their strengths and weaknesses, they get a personalized curriculum, and they can learn the subject at their speed. And if this content comes from a very high quality source, then that extremely high quality education can be dispersed to everybody in the world, as long as they have a computer, and that's all you need. So that would be really cool. And so that's like one area that I'm really excited about. I know a few companies that are doing that, and recently I mentioned Conmigo. Another example I can give you is Duolingo Max. So Duolingo, as you know, is an online site that helps you learn languages. So they have also partnered with ChatGPT to basically create a bot that will talk in whichever language you're trying to learn. So, Spanish, then it'll talk Spanish. So that's like another cool way of learning a language, because now you have a buddy that you can talk to in whichever language you want to learn. So I think I find that also pretty exciting.
I was gonna geek away on like how Camingo, is it Camingo you call them?
Yeah.
How that's actually working. How did they put that together? But that might be a different conversation. But yeah.
Yeah, I mean, we can talk about it quickly, but I don't know how they did it, but basically it's a ChatGPT chatbot. So I suppose you can fine tune it to be more knowledgeable. That's one. And the other is there is this thing called retrieval augmented generation, which has become quite popular now. This technique, you can actually see it happening in Bing. So when you ask a question, if it doesn't know the answer, then it'll go fetch the more information from the web. So these kinds of systems are definitely on the rise. These retrieval or retro kind of systems. So yeah, a hybrid of a database, and the chatbot, which can provide you with a degree of reasoning and a natural language, definitely.
Yep.
Then there are others also, like chat. So if you have heard of ChatGPT plugins, then there's this whole kind of, I would say, revolution that's going on right now, which is kind of using LLMs as a controller. So you give it a task, and then it breaks it up into steps. And for the steps where it doesn't have, for certain steps, it decides to call an API. For example, it could call Wolfram Alpha for solving some equations. And then the result comes back, the result gets inserted back into the context of the language model, and then it proceeds from there. So that's one technique that I'm aware of, which is still pretty nascent, so we don't know how far it's going to go. But the ChatGPT plugins, I suspect, are being developed along the same lines. So this is my guess how they would have.
How they work. Yeah, that makes a lot of sense. So I would shift gears a little bit, and I would like you to get into contextual learning, as it pertains to deep learning. I did a lot of work in the semantic, learning space, so definitely context is something that comes into play when we have those conversations. So I'm really curious to really pick your mind on what's contextual learning to you, and what how does that play into the deep learning paradigm?
So I'm assuming you're talking about what they call in context learning.
Correct.
Right?
Yes.
Yeah. So I guess so. There's this paradigm that's been called few shot learning. It's been around for some time. And there was a branch of that was called meta learning. So personally, I've spent a lot of time investigating in context learning. So I can definitely speak to that. So going back a few years, meta learning was one thing where the idea was that you teach the model to learn, and that was work that came out primarily from UC Berkeley. One of the main authors that I'm aware of is Chelsea Finn. She's at Stanford right now. So they have developed pioneered this technique of meta ML. So that was one branch where you would actually teach the model to learn, and which actually meant that you would have a loop going on, a backpropagation loop inside your training loop, and then you would backprop on top of that. So there will be like second 2-degree derivatives going on inside. So that was one branch. And then obviously that required training the model upfront to learn. And then during evaluation, or when you productionize it, or at inferencing time, no more learning happens. Whatever training happened, it happened at training time. And after that, the model is fixed, the weights are fixed, and it has some ability to learn. So you can give it examples of what you want it to do. So those are the few shot examples. So you give it multiple examples of what you would like it to do. For example, take auto grading. So you would give it, for example, the question and a sample answer and the grade. And then you give it another sample answer and grade, and another sample answer and the grade. And finally, you give it the answer that you actually wanted to grade. So, and then, the model is expected to look at the examples, learn from that, and repeat that on this last example, which has not been graded, so that it would go ahead and grade that. Now that's like, the kind of the theory or the objective. The other branch came out, as far as I remember. Okay, so actually before that, there was another one where few shot was, it was not meta learning. And what you did was, during training time, you would give it a few examples, like I said, and you would train it to work on the query example, the last example, which had not been auto graded, for example. So that was another kind of set of another thread of exploration or research, which was not meta ML. Now, that's what people were doing most of the time. And then the GPT-2 and 3 papers came out, which claimed that these models, you didn't have to train them up front for doing few shot learning or in-context learning. You just train them with the pre-training objective, which is just produce the next token, which is the GPT is generative pre-training, and the way it is trained is you give it a sentence, and then it's supposed to predict the next token, and then the next token and the next token, and that's how you train it. So just using the pre-training objective, if you just train a large model, they said that now you could, at runtime, at inference time, now you could give it these various few shot examples, and it would actually work without ever having been trained to do so. And so, they tried with like 60 examples or 30 examples in various cases, and they got results. Then there was another thing called zero shot. In zero shot, you would not give it a single example. You just tell it, this is what I want you to do. In this case, you would say, please grade this answer. And you would give it the question, the answer, and it's supposed to grade it. And you might say that this is a rubric that you're supposed to apply to grade this answer, one from 0 to 1. And if the answer has this, then give it 1 point, 2 points, whatever. You just tell it what to do, and then it's supposed to do that without having been given examples of that task. So that was zero shot, and there was some evidence that zero shot was actually happening in GPT-3 as well, and then the later models. So this thing kind of caught on, and finally it got the name in-context learning. And there is debate about whether actually any learning is happening. I don't believe any learning is actually happening. I think it's just predicting tokens. I shouldn't say just predicting tokens. It is predicting tokens, but in order to do that, it has to model the world internally, and that's why it's able to do all the wonderful things that it does today. But so long story short, then came instruction tuning. So after the generic pre-training, you would have another data set where you would maybe have a conversation with the model, And this entire conversation is what the model was supposed to be trained on. And so that was instruction tuning, which in the case of OpenAI, they did that with reinforcement learning. So they call it RLHF, reinforcement learning with human feedback. And they have a system for doing that. Other labs and other researchers have done it without reinforcement learning, just using plain gradient descent. So in both cases, now what happened is that when we see ChatGPT, we don't give it examples. Before that, in the GPT-3 playground of OpenAI, you actually gave it examples and you expected it to follow those examples. With ChatGPT, we don't. We just say what we want. We just ask it a question and it does that. So that's basically what in-context learning is, and it's because now that the pre-trained models have been fine-tuned to carry out conversations, therefore they can carry out conversations in the way that we have seen ChatGPT and all the other models, BARD, etc. So one final point here, I still don't think that there's any learning going on at runtime. So in context learning, I think we should drop the learning part there. And we should just say that it's a chatbot and it's able to chat. It's able to maybe emulate some personas. It's able to do a lot of emulation. So that's pretty cool. And that part, they call it emergent properties. And in one paper, like 137 emergent properties were identified a few months back. We don't know how that is happening. So for example, you could even, so I want to caveat this with saying that this is not reliable. So the example I'm going to give you. So you could ask it to pretend to be a Unix shell, a Unix command line terminal. And then you can give Unix commands, and it'll behave as if it was a computer. It doesn't always do it perfectly, but the mere fact that it's able to do it even half the time is pretty amazing, because it was never trained specifically to pretend to be a computer, like a Linux bash shell or a terminal. So, and these kinds of things, people have used this to write prompts for it to do a variety of things. You can ask, you can tell it to pretend to be some kind of person, and then it'll kind of go into that persona and start acting like that. So this is like just open research topic even now, but people have actually started relying on it. So that's kind of the dangerous side of it. A lot of apps have come out, and I don't know if there was one account of a journalist who had like a 2-hour chat with Bing, the early Bing, the first version that came out, and they kind of got into a fight, and Bing started being like rude and things like that. So, and it said things like, "I love you and you should leave your wife," and all that kind of stuff, which was alarming. Yeah. And so that's the thing about the reliability. I mean, this is still I would say this is still the research, and the fact that people started relying on it is a little bit concerning.
It is. So go ahead.
Yeah, that was very insightful to hear your thoughts about in-context learning and where you think it is right now. One other topic we were interested in discussing with you was regarding your publication on unconstrained full-page handwriting recognition. If you could share a bit more about that paper that you wrote and what you were working on in there.
Yeah. So this was full-page handwriting recognition, and a couple of things here. So the main contribution was that you take a full page of handwritten text, and the model will identify all the paragraphs in there, and it will then transcribe those paragraphs. If there are images, it's going to skip them. And we trained it to even skip the math portions. And instead of that, it will just emit a token which says like angle bracket math, angle bracket close. So, and the way this was done was we basically created a bespoke custom model, a custom architecture, which had not been used, which I had not seen anywhere before. And so there were two parts to it, and you can call it a cross-modal or a multi-modal model in today's language. In those days, people didn't really use those terms. So we took a CNN to work on the vision part, and one half of a transformer. So a transformer, for the viewers who don't know, is the model that powers GPT and all the large language models. And typically it would come in two parts. There was an encoder part and a decoder part. So I removed the encoder part and I replaced that with a convolutional neural network and trained it to predict the text that is inside a page. And up to that point, most of the, actually all the commercially, I'm saying all, but most of the work that had been published was worked in the following way. You would take a piece of text and you would identify the lines in there, and you would snip out the lines and make little images of those. And then each of those images now would be given to a neural network or another kind of model that would be expecting to only receive one line of text. And it would then produce that line of text. And then you would have to stitch together all these various lines of text that were independently produced by the model. The problem with this was you lost a lot of formatting information. So, two problems here. One is that the segmentation model, which the model which would actually cut out lines of text, that would not be able to work if the lines were curved, for example. So that when you write handwriting, many times, some people write it kind of the lines curve. In some places, the subsequent lines, it is far at one point, and then it kind of goes near, they come closer together. Now, if you want to cut this into a rectangular block, you are invariantly, in such cases, going to include parts of the neighboring line. Especially if the handwriting is curved, then there is no way to fit that entire line into one narrow rectangular block. Because then you have to cut a really big block, which is going to include a lot of text. So that's like one problem. Another problem is, suppose you have text that has like multiple paragraphs, and this line segmenter only knows, it's only expecting a single line across the board. So it's going to take like one line from the left. So I'm talking about two column formatting of text, and where you're supposed to read the first column first and then the second column. But the line segmenter is just going to just think of the whole thing as one line, and it's going to create a line that spans the first column and then the second column. So that's like another problem. So basically all the formatting that's there in the pages, that kind of, you have to then write special segmenters for different kinds of pages that have been formatted differently. In the case of handwriting, when people actually write, they will write a paragraph and then they'll put an arrow, and maybe there's a correction to be done somewhere. They will scratch off the handwriting someplace, and they will write a little bit tough on this. They will write side notes and all that. So all that needs to be, the model needs to be aware of that. And so we produced a single end-to-end model that would be aware of side notes, drawings, any other non-text that's been introduced inside. And so that was like one of the main contributions of this paper. And the second thing was that we actually paired a transformer with a vision model. So these days, that's happening a lot. So the CLIP models, for example, the CLIP model from OpenAI, which is a contrastive learning language image pre-training. So that model and all these multimodal models, now they have started to mix the modalities. But this was, at the time I was developing it, was the first one. When we actually wrote the paper, there was another paper which had done something similar, but they did that on single lines. And it was still a different model, but I have to give it to them that they also took a transformer and a convolutional neural network, and then they found a way to combine the two. So that's basically the contribution here. And when it came out, it was state of art for the specific task of full page recognition. And I don't know, maybe after that, maybe it has been surpassed by other models or not, but probably.
Sure, excellent. Thank you.
This model, I'm sorry, this model is it's in production in a Turnitin product.
Okay, great. Yano, any further questions?
Yeah, we're coming close to time here, but I wanted us to go in real quick into, some of the, because I want to go into the generative model side of the spectrum. Todd, if that's okay. Can I go right
Sure,
in?
sure.
So basically, I wanted you to sort of discuss where you see the generative models heading in the next 5 to 10 years.
Yeah, so this is like exceptionally interesting and exciting, as I'm sure you will agree, and a lot of other people will too. So the exciting part here is the emerging properties of these generative models. And but a scary part is what I alluded to earlier, that people are assuming that these are reliable, and then so software engineers have joined this party now, and they are developing applications which with the mindset that this underlying technology works like regular software, but the problem is it does not. So it is unreliable. And so that's one area I know researchers are working on to make it more reliable. The other thing I want to mention is multimodal models. So a merging of the modalities is happening. And the term you use, generative model, is the right one, because that can apply to any kind of modality. So everybody has seen Midjourney and Imagen, which generate pictures, or Stable Diffusion, which generate pictures. So that's like in the image space. There are models which will generate videos for you. There are models that will talk, and you can edit the speech by changing, by typing up. So for example, the speech, so there's a model, and there's actually an application where the speech, you record a video and the speech gets transcribed. Now, if you find some mistakes there, you can actually correct them in the text, and that gets reflected in the video. So these are multimodal models. The great thing about multimodal is that now you can speak to them, you can talk to them. And so another thing that's going on is embodied models. Again, I will put them in the same category as multimodal. So tomorrow you could have a Roomba that you could speak to, which would tell you what it's thinking. And that's what I find extremely interesting and exciting. So that's like the third part of what's going on, which is people are building systems by an ensembling, or by collecting together multiple models, or maybe the same model but run multiple times. And the interaction between these models is natural language. So now you can imagine a robot which has multiple AI models inside it, and those are interacting with each other in natural language. The robot is interacting with you in natural language, and the plan that it executes. So it first plans what to do, and then it executes the plan. So now it can tell you the plan, because that plan now is in natural language, and you can actually talk to it and change the plan. So if your Roomba is going in a certain way, you could actually ask it. I mean, this is not a product; it's not a reality. This is something I'm imagining. But I'm pretty confident that it's possible to build these kinds of products. Especially, so I'll give you one name. It's called AutoGPT, and there's another one called Baby AGI. So these projects are looking at taking an AI, an LLM, using it as a controller that emits a plan of what it's going to be doing. And that plan is in English, so you can actually see what it's going to do. And then, so this gives you an insight into these AI models or AI systems, which up to this point used to be black boxes. So that's the area of interpretability and explainability, which by using a system of multiple models, even though each model in itself is a black box, but now since the whole AI encompasses multiple models, we can actually see what they are talking to each other about. And that's how we can get an insight into what they're doing. So this actually starts to solve the interpretability and explainability problem, which has plagued neural networks in a long time. So like that's the third thing that I think not many people appreciate at this point, but that is very exciting to me.
Wow, that is super awesome. And
Thank you for sharing. Just one final question I have for you. If someone was interested in getting more into the machine learning game, kind of in the language and education spaces, any particular challenges that you've kind of encountered or you feel that would be helpful for them to be aware of to kind of help them get into that space?
Yes, I think at this point, I would ask them to take a different route. So if they're not already an AI scientist, and if they're an engineer, for example, so first thing you need to learn is Python, okay? And then you need to, you can just get directly into one of these frameworks like LangChain, AutoGPT, Baby AGI, etc. But I would say just pick LangChain for right now. So these are frameworks which are open source, and there are a lot of other open source projects that are going on. So there's a company called Together, there's a group called Leon, and Stability is also the company that brought Stable Diffusion is also another group that embraces open source, and it embraces contributors. So join one of these groups, and then you'll be on your way. And it's very easy now to contribute. Back in the day, you'd have to do a lot of math and science and write papers. Now you don't need to do that. If you want to be part of this, yeah, you need to learn Python, and then just join one of these communities, and that's what you get you a foot in the door.
Excellent advice. Thank you.
awesome. Thank you again so much, Sumeet, for coming. We really appreciate you. We definitely want to have you back because there's a whole lot of things that I know we would have loved to get into on this initial, but we're so looking forward to having you back on one of our sessions in the upcoming weeks.
Well, thank you very much for having me. I enjoyed it a lot. It's very exciting, and like you said, there's a lot to talk about.
Yeah.
So happy to jump back in anytime.
Oh, thank you so much.
All right. Thank you very much. We appreciate it.
Thank you again for joining another edition of the AI Innovation Space. We're looking forward to having you back soon.
This has been the AI Innovation Space, sponsored by Illumin. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Illumin website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.